Hello, everybody, and welcome to the ASME Dynamic Systems and Control Division podcast. I am your host, Brian, and today we have the pleasure to interview Dr. Jamie Lian. He's currently a distinguished R&D staff and the group leader of the Grid Interactive Controls Group. He has more than 15 years of experience in applying diverse methods from control optimization, economics, game theory, data analytics, and machine learning to improve the reliability and resilience, as well as security and sustainability of complex energy systems. He currently focuses on establishing a deep scientific understanding of building demand flexibilities and building the intellectual foundation of building to grid integration for enabling grid interactive efficient buildings. Welcome, Jamie, and thanks for accepting my invitation.
Yeah, thank you very much for having me today.
Great. So for those listeners who are not familiar with your research, can you tell us about the latest projects you're working on?
Okay, all right, it's my pleasure. So I'm currently, so as you just mentioned, I'm currently leading the Grid Interactive Controls Group, and this particular group mainly focuses on the R&D that delivers the innovative and multidisciplinary control solutions, trying to improve the power grid reliability and resilience, mainly through I call that everything to grid integration. Now, in particular, we have worked very extensively on building to grid integration, because building right now represents about 74% of the total electricity consumption in the United States. So that's why I'm currently mainly working on 3 projects with respect to building to grid integration. Now, I will introduce them briefly one by one. So in the first project, so we would like to rigorously examine the grid impacts of advanced B2G controls and trying to demonstrate their benefits in a more realistic setting. Now, very often, our research on advanced controls focuses more on how to improve the theoretical performance, but pay very less attention to how to practically verify the proposed control. Now, because in my opinion, the verifiability of advanced controls has greatly contributed to the industrial resistance of their adoption. Now, in order to accelerate the technology transfer of advanced B2G controls, we are currently establishing a high-fidelity, flexible research platform that matches the complexity as well as the scale of the ecosystem involving both the power grid and building. So this has been done through a modular hardware in a loop simulation design. So due to the modular design, this particular research platform we are developing can be easily configured to support the test and validation of different advanced control algorithms at different levels, all the way from the equipment to the building and also to the grid. Now, this platform also provides data, analytics, and hardware to serve the various needs at different stages of the control design process. So this is the first project I'm mainly focused on right now. Then in the second project, it's related. So we would like to adjust the deployability of the advanced B2G controls in practice. Now, besides the verifiability I just mentioned, I think deployability is another aspect that is often overlooked during the control design, but it will also greatly slow down the technology transfer. So advanced controls usually have to rely on data collection as well as the data analytics to achieve the desired performance. Now, therefore, the underlying information and communication technologies plays very crucial role in the control deployment. Now, that's why in order to deploy those advanced B2G controls we are developing right now, so which will utilize massive amount of data. So we are developing a high-speed edge computing infrastructure that can perform the data analytics and at the same time to deliver a situational understanding with the real-time data and networking bandwidth. Now, as a result of this effort, a network of edge devices with the computing power can span the distribution grid, usually the utility grid, to greatly increase the situational awareness and also support the deployment of the distributed control. So that's the second project. So these two projects here, basically, I try to address the issue specifically for the verifiability and also the deployability of any advanced control we are developing for the B2G integration. Then in the third project, it's sort of related. So basically, we are contributing to the establishment of the living laboratory for sustainable campus operation. Now, currently, Oak Ridge National Laboratory has a sustainability goals that require the energy use intensity for subject facilities to be reduced by 25% from 2015 to 2025. And also at the same time, they would like the use of renewable as well as the clean energy to be increased up to 30% and 20% respectively. Now, because commercial buildings are the major and also the biggest energy consumers on the campus, these sustainability goals can only be achieved through very aggressive steps to improve the energy efficiency of buildings. So that's why in this particular project, we work with the facility and operation staff within the lab here, trying to deliver a low-cost, scalable, across campus, robust and autonomous building energy management solution for an identified typical campus building, so that this building can serve as an energy hub to integrate the load flexibility within the building with all other various on-site distributed energy resources for more energy efficient and carbon-aware operations. So this is more like internal project. So we recently just got funded for this effort. We are really excited about this one because it's fully devoted to converting our lab here into a living laboratory so that we can directly apply our DOE-sponsored R&D results on the building into our own campus buildings to further support our own sustainability goals. Yeah, so here are three brief introduction of three main projects I'm currently working on.
Thanks. That is so interesting, and I absolutely encourage our listeners to Google Oak Ridge National Lab and this initiative to have this living campus where we are trying across the entire campus and all the different divisions we have to reduce our carbon footprint is definitely an amazing opportunity to precisely demonstrate all of these methods that we could use to decarbonize our society.
Yeah.
The other thing I want to emphasize is, as you mentioned, the importance of deployment, right? Especially on an academic perspective. It's when I remember when I was in my PhD, it was always nice to have your model running on your computer.
Yes.
Your plots look super nice, everything converges. And then you go to a deployment, right? And then things start getting more interesting. Then things don't work. Suddenly your controller becomes unstable and things like that. So it is really amazing, especially for in a national laboratory where precisely you need to transfer technology to be used in different markets. It's very important. So it's amazing, and yeah, I want to emphasize that point as well.
Yeah, because usually when we are doing the theoretical or basic research, very often we made a lot of assumptions about the real system. But once you move the control design to the real system, then these assumptions start to falling apart. So that's why. So basically, we need to keep that in mind when we propose anything new, because eventually you want someone to use your results rather than just something stay on the paper.
Absolutely, yeah, absolutely. So touching upon this more theoretical part of your research, when we when we first met some time ago, I was sitting listening to your talk about this transactive control. So I want you to share with our audience a very short definition of it, and what was your inspiration to develop this theory of transactive control?
Okay. Yes, thank you very much for asking this question, because before joining ORNL here, so over the past 5 or 6 years, I spent a lot of efforts on developing, I call that theory of the transactive control. Now, when transactive control was initially proposed, so it was mainly an engineering design that aims to incorporate economic concepts and principles into the control action. So that's how it was just originated. Now, before 2015, so there were 3 major field demonstration projects on transactive control in the United States, which were funded by Department of Energy. So these projects successfully demonstrated the field feasibility of this new technology, but the field results also revealed some issues with the control performance. Now, because the theoretical principles of transactive control were missing at that time, so these performance issues could not be explained and addressed. Then in 2015, Grid-wise Architecture Council so officially coined the term transactive energy. Now, for the combination of transactive control and electrical power system applications. Now, as a newly emerged concept, so many different names besides transactive control or transactive energy started to show up and also float around. Now, very soon, at that time period, so researchers started to talk about the same thing by using different names, or talk about different things by using the same name. So on the other hand, we can also see many works on this topic were published during the same time period. Now, these works, if you just spend time to read them, so these works are closely related but intricately distinct. Now, unfortunately, these intricacies are often not discussed in enough detail in those papers, and which could lead to very significant confusion or misunderstanding. And also, it requires enormous efforts for new learners here in understanding and comparing different results in the literature. So all of this basically during that time period, made me feel very frustrated. And then that's why I decided to formalize this new concept with more mathematical rigor by trying to develop the underlying theoretical principles. So I work with my friend, Professor Wei Zhang from the Ohio State University. So we started this effort. So we first defined the technical glossaries in order to establish the terminology, because for any new control, usually like PID control, linear control, so we would like to understand, to first have a terminology associated with a control concept here. So that's why we start to define different technical glossaries here. Now, in fact, so transactive control should not be used interchangeably with transactive energy. So although this is the case, very often the case right now. So this is because transactive control is actually the control approach itself. It's a domain-free approach, just control itself. However, the transactive energy is actually the resulted system by applying transactive control approaches into the energy system. So it's totally 2 different concepts here. So after we define the technical glossaries, then we started to establish a mathematical framework, trying to, as an unifying theoretical tool, to standardize the formulation and to facilitate the analysis and also streamline the design of any transactive energy systems. Now, our theoretical research efforts actually, I would say our theoretical research efforts turned transactive control from the original engineering practice into a science by providing a solid theoretical underpinning. So that was my aspirations in pursuing the theoretical development for transactive control. Because in my personal opinion, so transactive control is actually a very great concept, because it provides a way to coordinate and control a group of selfish entities, trying to make them work together to achieve certain global objectives. So the concept-wise is very great, very useful. However, without a formal theory behind the concept here, so it's very difficult for us to formally develop this particular control concept, and also it creates some barriers for the new learners to quickly understand, okay, how they can design the transactive control. So that was my initial thinking behind all the efforts there.
That is awesome. Thanks for walking us through all your experience and your process on developing this. And I think everybody, especially in these days, needs a way to grab different agents with different cost functions and make them work together, right? Why not? Yeah. It's a very noble principle. I like it a lot. So let's pivot a little bit. So why don't we now talk about your and my industry, which are national laboratories. So you have had a very productive career in national laboratories. You started first working at PNNL, now at ORNL. So what are the unique characteristics of national laboratories that attract you to work there?
Okay, this is actually a really great question. I asked myself the same question before. So because I have been staying in this system for more than 10 years now. Now, just in my personal opinion, I think national laboratory is unique in that the control R&D here, it's of great diversity and also of wide spectrum. So I can apply my control expertise to solve various problems of different systems, such as grid, building, transportation, and etc. Then I also have the freedom in the national laboratory to focus on either the basic research for theoretical development or theory development, or I can focus on the practical research for like product testing. So I have different freedoms here to decide what I would like to deal with. So basically, national laboratory provides a workplace where you can easily learn from different sorts of knowledge and skills. And at the same time, you can improve your communication and social skills. Now, I think what's more important here is you can also figure out what would be the most suitable type of research we would like to continue for ourselves, because you get in touch with so many choices, then you get an opportunity to really figure out what you really like. Now, if it turns out the R&D work is not what we really like to do for our career in the long run, you can also have an opportunity within the lab here trying to basically to try different positions. For example, you can try like line management, you can try project management, or also the program management. So which definitely require a different set of skills here. So basically, bottom line here is we got a lot of freedom within the national laboratory. And then there are many different career paths you can pursue. So you can decide how you would like to develop yourself. So I think that's the unique characteristics of the national laboratory, which attracts me a lot.
I completely agree with you. Yeah, I'm very happy to have this liberty and just to see all these colleagues that we have working in such an interesting project, and especially in a place where you have a lot of user facilities like the National Transportation Research Center or the Building Technologies Integration Center or the Manufacturing Demonstration. It's just amazing. Yeah. So that is.
Yeah, we also recently, I think we also get another facility dedicated for the grid research. It's called Grid C. So it's another big facility we are having.
Yeah, Grid C also. I've been inside the building once. You need to give me a tour of that.
Yeah, it's very huge.
Yeah, and so this was a very introspective question. Right, we are academics. We like to do hard things and find our problems and solve them. But now on a more global level, in your opinion, how important are national laboratories to the advancement of science and engineering?
Yeah, great question. So in my opinion, national laboratories actually plays a very critical role in the technology transition from theory to practice by serving as the bridge between the academia and the industry. Very often, because just from my personal experience, very often the academia and industry, they speak different languages. Now, national laboratory are kind of like the translator in between. So we have the right capabilities to understand the basic research performed by the universities, then also have the right knowledge of the real problem the company, the industry are concerned with. Therefore, we can help the universities to understand the industrial needs. Then at the same time, we can extend and improve the basic R&D results through technology commercialization to increase their adoption by the industry. So I think that's the very key role National Laboratory is currently playing.
Thanks for your opinion on this. So now for our student audience that we've been talking a lot about national labs today. These type of jobs are generally focused on applied research for engineering discipline. So what is your advice to our student audience that might want to pursue a career in a national lab as control engineers?
Yeah, there are, okay, first, technical wise, definitely you need to have enough or strong just education background in order to pursue a diversified set of researchers here. But I would like to talk about something more beyond the technical background here. So I'm basically speaking to my own experience here, because actually the first 2-3 years when I just joined the National Laboratory, I spent a lot of time trying to adjust myself in order to get used to the environment here. So first, I think it's very critical for students to be open-minded. Now, as I mentioned before, you will be working with various researchers of different technical background because of we have so many different work here. Now, it's not like a university where we mainly work with researchers of similar technical background. Now, here in the lab, you will need to learn how to respect those thoughts that could be totally opposite to yours. So that's first thing. Then second, I think it's important to practice the communication and social skills. You will need to learn how to introduce your ideas in plain language to others who do not have the right training to understand those technical jargons. Okay, so it's very important here. Now, furthermore, you will need to practice both public speech as well as the elevator pitch. So we all know the importance of public speech. Okay, so I will not talk about that, but elevator pitch is also equal importance. So because when it comes to sell your ideas for funding support, you need to really exercise your capability in delivering an elevator pitch. You will need to learn how to deliver your R&D ideas within a very short time period if you ever run into a potential funding sponsor in an elevator ride. So that's how as when I just joined the lab, all my managers just mentioned just talking about the importance of this skill. Because very often, if you go to DC to meet the DOE program managers, you may not have a lot of time to present your idea. You might only just get 1 or 2 minutes while they are working on the buildings. You just talk to them, trying to sell your idea. So that's why elevator pitch is a very important skill. I think the student need to learn how to practice, how to develop that. Then last item, I think it's very necessary to become very proficient in multitasking. Now, in national laboratories, each regular staff usually work on 2, 3, or even more projects simultaneously. It's not like a university where we usually work on a single project mainly, at most 2, but here it will be 2, 3, or even more. I have seen many cases that fresh PhD graduate fail to survive in the workplace, which require the multitasking. I think multitasking is a very important skill everywhere, which also applies to our daily life. So it's not just for work, but even in our daily life that require us to multitask. So I think that's another skill I think the students need to become more proficient. Yeah, so just 3 suggestions here.
Mm-hmm. Yeah, I completely agree. Yeah, as a very junior member of the national lab, communication is definitely key. Multitasking has been something I've been still working on, especially coming from a PhD where, I had one project that I had to focus on, maybe two. Yeah. So definitely the points that you mentioned are absolutely very important. Yeah. So great. So the last thing I wanna touch today, I wanna talk about will be more of a personal point. So throughout your career, you have been a very involved academic, not only having many high impact publications and patents, but also serving as an adjunct professor at Washington State University. So now as a group leader at Oak Ridge National Lab, I'm sure you have a lot on your plate. So I would like to know which activities you do outside your academic life that allows you to wind down, cope with the stress, or just have a good time.
Yeah, great question. Just to be honest, not much time. Well, we don't, just myself, I don't have much time to wind down, basically. So personally, I like gardening a lot. So I can spend my entire day in my home garden to take care of those plants. So that's my biggest hobby. So I really enjoy watching how different plants grow from the small seeds eventually to the flower or to the fruit. So that's why I really enjoyed. So it's actually very amazing about the life. So what you can see from those plants. So to be honest, gardening actually provides me much more sense of accomplishment than writing the proposal, because eventually you will get something, but definitely we need to keep writing proposal, but just sometimes it's frustrating. So just to be honest. Now, besides gardening, I also go fishing sometimes and traveling around. So I was planning to travel overseas every year, but did not make it due to the pandemic. So over the past 2 years, I wish the pandemic can be behind us soon and everyone can go back to the normal life. Yeah, but yeah, so basically just here and there trying to spend some spare times just to calm myself down. So that's it. Really don't have like a bunch of time to relax.
I get it. Yeah, that is awesome. You should teach me how to garden more. We have a bunch of fake plants in the house just to make everything greener. But I've been trying to keep a basil alive for more than 3 months, and every time I fail. So I will definitely need your advice.
Okay, I will.
Awesome. Well, thank you for your time, and thanks for this. This has been the first interview to National Lab staff. I hope our audiences like it. I definitely hope to have more people like you with your perspective here. And yeah, thanks again for your time. It was great. I enjoyed it a lot.
Yeah, you are welcome. It's my honor to learn that I'm the first one from the National Laboratory. Thank you so much.
Yeah. Well, yeah. Thanks for your time, Jamie, and I'll see you later then.
Okay, thank you.
Okay. Bye.
Bye.